All right, I'm going to work it now. All right, so the two important things. So, as you know by now, right? You get the halo alkane, you see differing by these two, right? You know it's the isotopes. If you had seen just 108 or a peak for just 110, it would mean that in that compound, you only have one of the isotopes present. Now, the key, a very important thing. By the way, how much carbon is present? Anybody? Two. If you notice, all of this region is empty. That indicates that no, you don't have a lot of carbons, because if you add like 4 or 5 carbons in the compound, you would have had fragments in the 40s or 50s or even 60s. But you notice all of here is empty and just have 1 at 29. That is a big indication that it's just 2 carbons present. And remember also, on any mass spectrum, once you see 29, what fragment is 29?
C2H5.
Right, C2H5. All right, so let's follow what we said, right, and work it out. So I had said when you have a haloalkane and you want the molecular formula of the compound, how would we calculate it?
You subtract?
Subtract what? Yeah, exactly. Exactly what we would subtract.
Subtract the mass of the alkane, the halogen.
Right. So formula of haloalkane. So let us say, all right, so let us work with the 110. So that's the mass of the compound of the haloalkane. It cannot be chlorine. I hope you can see that, right? Could it be chlorine?
No, sir.
No.
Large number is, I don't think it will be chlorine.
Right. It's too large. So with just 2 carbons and this high number, it couldn't be chlorine. All right. But we will prove it as well. All right. So it is bromine, right? So haloalkane 110. The mass of the bromine is 81. So 110 minus 81, how much would we get?
Sir, exactly 29.
All right. So remember, 110 minus 81, what we are working out is the amount of carbons. So this is the mass of the halogen. The 110 is the mass of the molecular ion. All right. And we get 29. 29 is a carbon and hydrogen. By now we know that once it's 29, we should know that it is C2H5, right? And that means your haloalkane is bromoethane. All right. So we know that our fragment is 29. Now, so for part 2, it said deduce, given an explanation, the halogen present in the compound, and hence draw the displayed formula of the compound. All right, so if you had answered it, how did you arrive at your answer? If you want to share, how did you know it was bromoethane?
Sir, it's just a question. All if you use 180 was to get by the 29 centimeter.
Please repeat.
So if you use the 198, you can still get by the 29 centimeter.
Yeah, man. Oh, all right, so if you use the 108, which mass would you use? The 79 or the 81?
79, I think.
Right. You would use the 79. And you would get back 29. Because the 108 is for the lighter isotope. And the 110 is for the heavier isotope. Is that clear?
Yes, sir.
All right. All right. All right. So look, when we look at this compound, right? We only have one fragment, right? Which is 29. That tells us it has this compound. It consists of 2 carbons. Chlorine has a mass of how much? 35. So if you add a chlorine to that mass, it cannot give us 108. All right. The next halogen is bromine. Bromine has a mass of 79 and 81. When you attach that to the ethyl fragment, it gives you the 108 and 110. Hold on, some comments. All right, let me see. So why do you use the 110 instead of 108? All right, so remember, from we started out, the peak at the end, the molecular ion is always the one at the end, the heaviest one. All right. So you use 110. However, this is an isotope. We now know that this is bromine. It has mass of 79 and 81. So when you're using the 110, you have to use the heavier isotope. And the 108 is the lighter isotope. So we use the 110, that's the heaviest ion. That's the molecular ion. All right. With the heavier isotope. So question, would the structure for the 108 fragment be different from the 108 fragment?
So you mean from the 110 fragment to
Yeah, would the structure of the 108 and 110 be different or the same?
No, the same, sir.
Right. Right. So that is haloalkane. Right. Hold on. They are yes, they are isotopes. Is Kathleen or Caitlin? Yes, so right, they are isotopes, so that is why the structure would not change. So it's just that one atom is heavier. All right. All right, now we need to do an ester. 9:55. I'm going to clear the board and we're going to do an ester.
Sarah, did we give the explanation?
Let me write it.
Just the explanation, right?
Hmm?
That was just the explanation, right?
Once again.
That was just the explanation, right? Of how we
Right, yes.
I want
However you
Can
figured it
I
out.
write it, please?
No, it's how you figured it out. All right, I will tell you how I figured it out.
so I just want to know like how that word it.
Hold on. Did you figure it out?
Yes, sir.
Right, so with this question is however you figured it out, right? All right, so let's look again. Let me just erase this. Right, so one, you know it's a haloalkane, right?
Yes, sir.
Yes. So this, what I'm doing now is how we arrived about the, it says to explain how we got the, where is it? Where's the question? Find it back. About using, giving an explanation for the halogen present. Right, so for the first thing, we know it's a haloalkane, right? With a mass over 100. All right, so it's heavy. Second thing you notice, right? How many actual fragments are there?
One.
One. All right. So you have a mass, right? You have a haloalkane with a mass of over 100, but you only have one fragment. question, if we say this is the molecular ion, right? Is the 110 a fragment? Sorry, is the 108 a fragment? Fragment means when the molecule actually pick up.
No. No, sir.
Right. So the only fragment is the 29. All right. So it's an alkane, the haloalkane with a mass over 100. There is only one fragment and it has a mass of 29. Wait a second, let me read this. So in this structure, do we need to write this 79 and 81? No. I'm going to undo because some people did not screenshot. Right. So there is only one fragment and it has a mass of 29. That means the halogen in the compound must have mass of 110 minus 29, not 28, 110 minus 29. No, wait, yeah, 110 minus 29, that is 81.
Sir. Oh, yes, sir.
Right. So that means the halogen in the compound must have a mass of 110 minus 29. So the only fragment has a mass of 29. So that means your halogen is 29 from the mass of the molecular ion. Right, let me, hold on. It must have a mass of or equal to, input equal to, must have a mass equal to the difference between the molecular ion and the fragment of 29. All right, so that's all we know. It's a alkane, it have a mass over 100. You only have basically step one, looking at it now, you don't have to put it, you can make it stay for your purpose. All right, so it's over 100, there's only one fragment, is 29. You subtract this fragment from your molecular ion, you'll get your halogen. All right, so 110 minus 29, 81. Subtracting the base peak from the molecular ion. We determine the type of halogen by subtracting. No, don't use the base peak. This one is just coincidence. So how we normally do it, we would subtract the halogen from the molecular ion. Okay, all right.
That's what I did, and I realized that you did it the other way around here from me. So I don't know. I just did like a trial and error with the different mass numbers, and so that's okay to just do the trial and error. Like I did 110.
No, ask the question. You did 110 and?
I did 110 minus 81.
Mm-hmm.
Trial and error with the different mass numbers. Well, just trial and error with that mass number, then it just turned out to be that. So it's okay if I just do that instead of subtracting the 29 from the 110.
No, all right, so the 20, right, so as I was saying, right, subtracting the 29 from the 110, it's very specific to this scenario. So the reason why we did this, right, when you look at this mass, so they're asking how we know which halogen it is. When you look at this, right, these two here, they are actually molecular ions. They are not fragments, right? So these two are bromine atoms. Good. The only fragment of is 29. So the only number of carbons present in a compound is 2. That is why we just subtract it. That is why we are telling them that to know which halogen is present, all we had to do was subtract 29 from the molecular ion. Is that clear?
Yes, sir, but I was asking if it's also acceptable for me to just do trial and error the different mass numbers to determine which halogen is it, because that's what I did to find out that is bromine 81.
In this example,
Yes, sir. Like where you have the 110 minus 29 at the bottom, I
oh, yes, so you did the 110 minus 81
yes, sir.
to get 29.
Yes, sir, and that's okay as well.
Yeah, man, that we did not. If you look over to the left-hand corner,
Oh,
yeah, that's what we did. 110 minus 81 equal 29
okay, sir.
atoms. But only fragment of is 29. All right, so I'm going to undo. All right, so take a screenshot of this. Then I'm going to quickly undo for the other screen so some people can get it.
Question, sir, just to be clear.
Yeah.
You said that we basically subtract the 29 from the 110 to realize that it was bromine. And in the chat I asked if we could do this for everything. So you're saying that we couldn't do this for any other problem, it's just that it's a coincidence?
That's subtracting the 29 from
Yeah.
the, because
or generally the base peak from the molecular peak to find what halogen it would be.
wouldn't the base peak, generally the base peak don't have it in the halogen. So normally what we would do, take a fragment that we know have in the halogen.
But
Where you
sir,
hear,
what if you're clueless and you don't know the halogen? That's what I'm talking about.
but we did that a while ago. No? You hear earlier? Were you here earlier when we were doing chlorine?
Yes, sir, I was.
Right, yes, so that was the easiest way I saw to help you. I don't want you to waste time trying to figure it out. Right? So if you get off, what I would suggest, right? You get a haloalkane, you subtract, look for a fragment. So remember now, right, 63. I don't remember the exact question, but look for a fragment. Good? Not the 12, sorry, not the 15, not the 43, not the 29. All right? Those are hydrocarbon fragments. Good? Look for a fragment and anything outside of the norm. For the 15, 29, 43, 57, 71. All of these are hydrocarbon fragments. 63 is not one of these. So if you have a fragment, right? It is 63. Could the halogen be bromine? Quickly.
No.
All right. Could it be iodine? No, because it's over the mass of iodine over 63. So it would be between fluorine and chlorine. So you just work it out. If fluorine matches up this fragment, it's fluorine. If chlorine matches, then it's chlorine. But the two of them will not give you the structure you want. Only one of them will. Understand?
Yes, sir.
All right. So we need to do an ester. So I need to undo this. So I'm going to, this is going to take a while.